I welcome you to my YouTube channel. So, in this series, I'm going to discuss with you previous year questions. So, today, I'm going to discuss with you how to find out maximum work done and the log Kc for this given cell reaction. Right. So, first, let us find out the value of log Kc. So, let me write the equation to find out log Kc. Log Kc is equal to E naught cell into n divided by 0.0591. So here you have to find out what's the value of E naught cell and the value of n. So these two things we need to know. So how to find out E naught cell? For finding E naught cell value, you know that ER naught minus EL. Here, let's first talk about how to find out which one is ER, which one is EL. That can be done in two ways. The first way is look at which one having smallest value. So let me write here, write the values of E naught here. E naught nickel plus 2 to nickel is equal to minus 0.25 volt, and the next one is E naught Ag plus 2Ag, the value given to be plus 0.80 volt. Now I'm going to compare these two values. So the smallest value is minus 0.25. So this is going to be my anode. So this is going to be my cathode. Or what you can do to find out the which one is acting as the anode and cathode, from this cell reaction we can do that. So let me write the cell reaction. So nickel plus 2 Ag is in equilibrium with nickel plus 2 plus 2 Ag. Here just observe the powers, the charges. Here nickel converted to nickel plus 2. Here oxidation state is higher, which means that it is undergoing oxidation. Now compare the oxidation state of silver. Here Ag plus, here Ag 0. So plus to 0, it reduces. This undergoes reduction. So as we know, all know that at anode, oxidation takes place. So here nickel gets converted to nickel plus 2 by loss of 2 electrons. Whereas at cathode, Ag plus converted to Ag. For this conversion, it needs 1 electron. So to add this, I have to ensure that how many number of electron lost and how many number of electron gained. This number should be equal. Here 2 electron lost by nickel to get nickel plus 2, but whereas for this conversion is just require 1 electron. To make it equal, I can multiply the entire equation by 2. Now I'm going to add these two equations if I'll be getting the same thing once again. So what I can do is, so here nickel plus 2Ag plus gives nickel plus 2 and 2Ag. So from this I can calculate how many number of electron involved. So this is the actual method. So if you want to find out the shortcut, so just compare these two numbers. If these two numbers are same, you can write the number of electrons involved to be same. Otherwise, I have number 1 here, I have number 2 here. If you just multiply them, you will come to know how many number of electrons involved. So in this equation, I have now found what is the number of electrons involved. So to find out this one, I can now use the same formula ER minus CL. ER here is 0.80 minus EL value here is minus 0.25. Minus of minus will become plus 0.05 volt I'm getting. So now the next step is to substitute in the formula. Log Kc is equal to E naught cell into N divided by 0.591. E naught value what I found 1.05. Number of electron involved here is 2 and then 0.0591. Listen, if you simplify this, I will be getting log Kc value to be 35.53. The question they are asking you log Kc. You can simply mention this as your answer. And we have found the value of log Kc. Now they are asking you to calculate maximum work done. So what they are asking? They are asking delta G naught. If you calculate delta G naught, it's nothing but maximum work that can be done when this reaction is performed. So what's the formula of delta G naught? Delta G naught is equal to minus NF E naught. We know that the number of electron involved in this equation to be 2, and then Faraday 96,500. E naught value we found it to be 1.05. So when we multiply them, we'll get the value minus 202,650 joule per mole. So now if I want to calculate the values in kilojoule per mole, what I can do, I can simply divide it by 1000. So I will be getting minus 202.65 kilojoule per mole. So this is my delta G naught value. Thank you for watching.